All right, for one definition, we're going to talk about the complement. All right, by definition, the probability of the complement of an event. So that's E with a line over it, or E bar. All right, that is the symbol for the complement of an event. The complement of event is the likelihood that the event didn't happen. And you can calculate it manually by doing 100% minus the probability of the event happening. Sometimes it's easier to count all the ways you can't do something than it is to count the ways you can do something. Other times it's the other way around, and you want to find out how many ways you can't do something by counting the ways you can do it. Now, one way to think about this is with Venn diagrams. So I have a box which represents the universe, all of my events. I have segregated a portion of my universe to create everything that is E. Now, everything that is on the outside of that circle, by definition, is everything that is not E. And you notice the symbol I use for this is E with a bar on top of it. Now, there's other books that use other notations for the complement of. Some will have an E with a superscript of the letter C to represent E complement. Others will put a squiggle or a tilde in front of the E. Others will do, it's kind of a sideways L pointed down with an E. And all of these mean the complement of the event, or not the event. Just different books, different families of scholars have used different symbols to represent the same thing. Now, if we're looking at rolling dice, all right, if I ask what's the probability of not rolling a 6, there's two ways that I can look at this. I can look at all my possibilities in my sample set, and I have 1, 2, 3, 4, 5, 6. Not getting a 6, I could circle these guys. Getting a 6 is doing that. So the likelihood of not getting a 6 is 5 out of 6. Right? So I can directly calculate that. Now, I also could have looked at the complement, and you see how 6 is outside of that circle? And I could have said that, oh, this is the same as 1 minus the probability of getting a 6, which would equal 1 minus 1 over 6, which is equal to 5, 6. Now, for this example, we could have done it either way. It was just as simple. But sometimes, and we'll have examples in the book, it's easier to figure out the complement than it is to find out the direct probability.